Hi, I wanted to do a little review on identifying distal structures, proximal structures, medial structures, lateral structures, and discuss medial and lateral rotation of the upper limb. So what we're looking at here is the skeleton and anatomical position. As you can see, the arms are turned out so that the thumbs are pointing away from the body. That when you make that motion from your hands, say when your hands are hanging, down at your sides, your palms are facing your thighs. But as you laterally rotate your hands to take your thumbs away from your body, to point your thumbs out away from your body, we call that lateral or external rotation. So we're going to be talking about positions and whether we rotate the arm or the hand laterally or medially. So when we take our thumbs back towards our body and point our thumbs in towards the middle of our body, we call that medial or internal rotation. Okay, so this person is in an anatomical position, which is a laterally rotated arm with the thumbs pointing away from the midline. All right, so their palm side is facing up. So when we look at the smaller parts, like the individual, say the individual phalanges or the metacarpals, we talk about the lateral side of the phalange, the medial side of the phalange, right? The lateral side of the metacarpal and the medial side of the metacarpal. So we have to remember we always do that in reference to the palm side being out, the hands being rotated out laterally in an anatomical position. So any part of, let's take the second digit. Let's look at the second digit. Let's look at the metacarpals, right? So we've got the metacarpals here. Let's look at the second digit. The first digit is our thumb, second digit here. The side of this metacarpal that is closest to the thumb would be the lateral side of that metacarpal. And then the medial side is the side of that metacarpal that's closest to the midline of the body. So each phalange and metacarpal have their own lateral and medial sides, and that's important to us in X-ray because we have to identify the projection of the beam. Where is the beam entering and exiting? So up until this point, we've really been talking about just a straight lateral beam. But in lateral positions of the digits and the limbs, we are very specific as to whether that beam enters the medial side of that phalange and exits the lateral side of the phalange, or does it enter the lateral side and exit the medial side? So if in our lateral position of the finger, let's say our X-ray enters the lateral side of this digit and exits the medial side of the digit, we would call that a lateromedial projection, lateral-medial projection. Now on the opposite, if the projection, the beam enters the medial side of that digit and exits the lateral side of the digit, then we would call that a medial lateral beam. So you can see where it's very important to remember we have to put our palms outward and go by an anatomical position of the hand to decide whether we're looking at the lateral or the medial side of those individual digits, all right? And that's going to become very important when we start looking at the positions of our digits, okay? Because we're going to turn our digits when we do our x-rays. We have to turn the hand in a way that it will take that digit and put it as close to the IR as we can to eliminate as much of the OID as we can to avoid magnification and penumbra that could be caused by the magnification. So that's why it's so important to understand lateral, medial, medial, lateral, lateral rotation, thumbs going away from the body, medial rotation, thumbs going towards the body. All right, so let's talk about proximal and distal. All right, so anything where proximal, the most proximal part of a limb or your bone is the part that's closest to the point of origin. right? So we could say with the upper limb, if we're looking at the entire upper limb here, we could say the point of origin here is at the scapula at the shoulder joint, right? So the upper limb, so this is the most proximal part of our upper limb, that humeral head here. So anything that's working its way away from the body is more distal. So we could say that the phalanges, right? The phalanges are the most distal. We could say that the metacarpals are more proximal than the phalanges, right? We could say that the carpals are even more proximal than the metacarpals are. And then, of course, the radius and the ulna are more proximal than the carpals. Or we could say that the carpals are distal to the radius and ulna, or that the metacarpals are distal to the carpals. The phalanges are distal to the metacarpals. You see? So they'll ask you questions. So when we get into the elbow, we'll be talking about, the ulnar tuberosity. We'll be talking about the neck of the radius, the head of the radius. So let's take these two very small structures that are very close together, but we need to be able to identify that the head of the radius is more proximal than the neck of the radius. Now, the neck of the radius is more proximal than the radial tuberosity, which they're not labeling it here, so those structures, as we learn them, you kind of see it like sticking out right here a little bit. There it is, the radial tuberosity, right? So we can say the radial tuberosity is more distal than the radial neck. The radial head is more proximal than the radial neck. We could say that the capitulum of the humerus, part of the humerus here, right, the capitulum is more proximal than the radial head, right? We could say that the capitulum and the radial head, they articulate, but the capitulum is the more proximal of those two structures when we talk about the structures. So it's going to get very specific and very in depth about all of these little areas here. We need to know the coronoid fossa. We need to know the radial fossa. That's where, when our elbow bends, the radial head fits in the radial fossa. So the fossas are named by the bone that sits inside it. This is the coronoid fossa because the coronoid process of the ulna fits in that fossa when we bend our elbow. All right, so I just want to give you a little idea of how detailed this can be, right? So we could say the medial epicondyle, right? It's the medial epicondyle because it's towards the midline of the body. This is the lateral epicondyle because it's towards the lateral side of the body. All right, so knowing proximal to distal. Also, when we learn the carpals, okay, we're gonna be talking about the carpals. Let me try to pan this out a little bit up and then zoom it in if I can. All right, here we go. Okay, so like this, looking at the carpals, you see how there are two rows of carpals. There's a distal row of carpals, a distal row that's closer to the metacarpals, right? The proximal row of carpals is closest to the radius and ulna. So this is the palmar side of the hand. And then also, when you're learning the carpals, you need to learn them by the distal row and the proximal row, but you also will need to learn them from lateral to medial and back medial to lateral, because you never know how they're going to ask you on an exam to list the distal row of list the distal row of carpals from medial to lateral. Or they could say list the distal row of carpals from lateral to medial. So you have to know them, from side to side, and which row is the most proximal row, which is the row that's closest to the radius and the ulna, and which row is the distal row, which is the row that's closest to the metacarpals. So I'm going to do a more detailed video of the bones and the structures from the hands up to the forearm and the elbow in a different video. So thanks for watching. I hope this was helpful.